Hello everyone, welcome to Skill Dev. Trey here, and in this lesson, we are going to solve product array. The prompt states you're given an array of integers as the input. You need to write a function that returns an array of integers where each item is the product of every other item from the input array. So for the input 1 through 5, at index 0, the answer is 120. You skip 1 and multiply 2 times 3 times 4 times 5. At index 1, it's 1, skip 2, 3 times 4 times 5. At index 2, it's 1 times 2, skip 3, 4 times 5. And it's just this same logic for every item in the array. This question also has some very strict constraints. The first is that you can't use division. So if we could use division, we could very easily find the total product, then iterate through the array and divide this total by each item, which would then just be the product of every other item. Since we can't do that, we're now going to have to get a little more creative. The question also states that the results array won't count against your space complexity. But memory is a concern in this question, so you need to try to limit the use of your additional data structures. We can quickly recognize a brute force solution. We can create a double-nested for loop where we iterate through each item, and then we multiply every other item together, but we skip by the current item's index. The benefit to this solution is that we don't add any additional data structures, we only use the results array. However, the downside is that we have quadratic time for the time complexity. This is just unacceptable, and we need to think how we can optimize to fix this. So now let's visualize what's happening. This is just our brute force solution, but with all the calculations written out. We see here in these first two lines, for the 0 and 1 index, we have this pattern of 7, 10, 15, 31, repeating itself 2 lines in a row. We also see, when we get towards the end, we have other patterns forming on the other side with these previous patterns disappearing. So like the last 2 lines, we have 2, 3, 7, and 10 appearing sequentially. Anytime we see repeated work like this, we know there has to be a way to optimize it. So let's dig in further there to figure out what we can do. And now let's highlight the repeated work. We can see this problem is almost broken into 2 halves, where there's repeated work in the left half and the right half when you're looking at any index. And if you move through the items, it kind of shifts around each index, where the right half is losing 1 item each time, and the left half is gaining 1 item each time. So then to calculate the answer at any index, we just multiply the left half items times the right half items. Instead of saying the answer at any index is the product of all other items, we're actually saying the answer at the index is the product of all the items to the left and all the items to the right. And then we multiply these values together to get the current index's solution. So if we look at the solution at any index, we're kind of creating this running product where if we know the answer to the left and to the right, we can multiply them together to get the answer at that index. Specifically, we're building this left side up from the beginning, where we have 2, then we have 3 times 2, but if we remember this 2 value, then we just multiply 3 times the previous value to get the left half. Then, instead of recalculating 2 times 3, we just multiply 7 by the previous calculation, and so on for each index. So we're building it up where we have 2 times 3 times 7 times 10 times 15, and we store each previous step, and then we don't have to recalculate any of these extra values. So this is what I mean by creating a running product. Then on the right side, we're just building up from the end instead of the beginning. So we have 31 times 15 times 10 times 7 times 3. And this removes all the unnecessary work here. And then to find the solution at any index, it's just the left running product times the right running product at the index that we're looking for. So what's the best way to store these running products so we can reuse them at each step? So if we want to find the running product for each step, you would want to know the running product for the left side at 0, at 1, at 2, at 3, and so on. So this means the best way to store them is going to be using an array. Specifically, we'll have an array for the left running product and the right running product. We start with 1 because the product at the 0 index is just going to be the items to the right, and then if we multiply that by 1, it won't change the value. But then also as we build up our left product array, by starting with 1, it's just 2 times 1, which is also this identity, which means it's only 2. So we put 1 in the 0 slot, then do 2 times the left product array of 0, and then do 3 times the left product array at 1, and then 7 times the left product array at 2, and so on. And then we build up our product for each index, starting from beginning to end. With the right product array, we just start at the end and work our way towards the beginning. And once again, the first value is 1. Then to calculate the answer at any index, it's going to be left product array at the index times right product array at the index. Let's quickly run through this just to get some more intuition. So the left product array is 1, then 1 times 1, then 2 times 1 times 1, which is just 2 times the previous value, and then 3 times the previous value, and so on. And then with the right product array, it's just the same, but working from the other side. We get this output array where we have the right and left product at any index. And then to find the solution, or the result, it's just the left product array at that index times the right product array at that index. Then translating this to code, we initialize our left product array to an array of 1s, same for the right product array. Then we have one loop to build up the left product array for all the items. So left product array at any index is just the index before times the input. So we're building each left product array answer off a previous value. We do the same for the right product array. We just start at the end instead of the beginning. Then we iterate through the number of items in the array, and then take the left product at each index and multiply it by the right product at each index, and then push this to our results. And this will get the solution, but it's actually not perfect. We actually broke a serious constraint. We only want to initialize a results array, and memory may be a concern, so we want to limit our usage of additional data structures. And we broke that by adding 2 additional data structures, one for the left product array and one for the right product array. So how can we preserve this logic where we're building up our left and right product, but not adding any additional data structures? So the first question is, do we need both of these arrays? Do we need the left running product array and the right running product array? Well, we have these 2 for loops, one where we construct the arrays and the one where we use them. But with the left running product, we can actually just build it up as we go. So we initialize the left running product to 1. We don't use an array, so we just don't use it in this loop. And then we greedily calculate it each step of this second loop. So the left running product at each step is just the previous left running product times the input's current value. And then we wonder, well, can we do this for the right running product? And we actually can't. When we use the right running product, it's all the items to the right multiplied together for that first value. And that's at the 0 index. If we went to the 1 index, it's actually a smaller number, so we would have to divide by the item at the 1 index to get to that second largest number, which will not work. This won't work because we're not allowed to use division in this problem. So we actually still have to store our right running products in an array itself. So then how can we do this? Well, we have this results array that's just an empty array and unused, but it doesn't count against our time complexity. So what if we stored our right running product here instead? Then at each item, we replace the right running product with the answer for that slot after we use the right running product. So we fill in the answer over the right running product as we go. So we just initialize the results array to an array of 1s, then get rid of the right running product array, use results in our first for loop, and then we calculate the current index's answer by taking the results array at that index, which is currently just the right running product, multiplying it with left product, and then we replace the right product with the answer at that point to get our solution. So just to walk through it, we have this input array, our left running product is initialized to 1, and our results array is the right running product. Then at the first item, it's left running product, which is 1, times the right running product, which is 120. So as we saw in our results, the answer is 120 here. Then we recalculate the left running product, which is just the input first item times the previous left running product, which is 1, so it's 1. Then 1 times 60 is 60. We recalculate the left running product again. 2 times 1 is 2, or 2 times the previous value. And then the left running product times the results at this item is 2 times 20, as we saw before, which is 40. So now the spot here becomes 40. Then the left running product is 3 times the previous value, which is 6. Then we do 6 times the results array at this item. 6 times 5 is 30. And then finally, we do 4 times the previous value. So left running product is 24. And then we do 24 times the right running product, which the final item is just 1. So 24 times 1 is 24. And that's our solution. We greedily calculate the left running product, and then we add the right running product to our results array. We iterate through the array, and we calculate the current left running product by taking the previous left running product and then the input at that index. The results array is our right running product, so we just take the value at that index, multiply it with the left running product, and replace it in the results array with the answer. This is going to operate in linear time, so we iterate through all n items, and it's only going to take O of 1 constant space. We were told the results array does not count against our time complexity, so using it as a data structure added nothing. Then we used a variable for the left running product, which adds no additional data structures, so overall it's just constant space fulfilling that constraint. And now we're ready to write our solution function, build product array. We start by initializing our results array, and we're going to fill it with 1s because it's also going to hold our right running product. And we initialize the left product to 1. The left product we're going to greedily calculate, so we don't need an array. And now we're ready to write our for loop to calculate the right running product at each index. Notice we start at 1 instead of 0 like we typically do, because the furthest right item in the right running product array is just 1 already, which we filled in, so we want to move 1 item to the left of it. And then we want to calculate the index for the item we want to update. Length minus 1 is the last item. And then we do minus I to figure out how many items into the array our current index should be. Then we update that value, and it's the previous value or the value to the right, which is end index plus 1. We multiply that for the input at that index as well. And that's all we need to calculate our right running product. And now we're ready to calculate the results at each index. So the product except self, or the answer, is just the left product multiplied by the results at that index. So all the items to the left multiplied by all the items to the right of any given item. Then we just update the results at that index to be this answer. And finally, we update the left product to be the previous left product times the input. So we're continually, greedily calculating this left product and building it up off the previous left product and the current item to get the product of all the items to the left. And this will yield our solution. So now we just return results. We run our code and our tests pass. So in this question, we really thought through how to use arrays, how items relate to each other, and how to iterate from both the beginning and the end. Thanks everyone, and I'll see you in the next lesson.